Hi guys, here I go. I'm doing one more video, review video for my Algebra 2 students or anybody taking Math 125. So we're going to be doing function composition. So function composition is when I combine two functions into one. So I can have f of g or g of f. And so these mean the same thing, f of g of x and g of f of x. So the easiest way that I can describe this is I can look at these in two different ways. So I use an analogy of a pregnant lady and a baby. So who's the pregnant lady on this one and who's the baby? Remember, the baby is inside the womb of the pregnant lady. So if you can see it, can you see that the f function is the pregnant lady and the g function is the baby inside? So hopefully you can see that. And over here, I have the g function is the pregnant lady and the f function is the baby inside. So what does this mean? This means that when the baby is inside, that function becomes the input of the pregnant lady, okay? Okay, so we're gonna go ahead and begin. I'm gonna do a quick little example, and I'm gonna say, let's see. So let's say I have f of x is equal to the square root of 5x plus 12, and g of x is equal to 2x squared, 2x squared, just 2x squared, okay? So we're going to go ahead and see what this means. So given that I have these two functions, I'm not going to perform f of g of x. So first thing I'm going to do is I'm going to perform f of g of x for that one. So I'm just going to write it here again just for sake of space. So I have f of x is equal to square root of 5x plus 12, and g of x is equal to 2x squared, okay? So the first thing I'm going to do is I'm going to find f of g of x. So what does that mean? That means that I'm using the pregnant lady as the bone structure, and I'm plugging in the baby inside the bone structure, right? Because the pregnant lady carries the baby inside her bones or within her bones. So again, I'm going to see, here's the bone structure. Look it. There's the bone structure. And what am I doing? I'm putting the baby inside the bone. So boop, 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 right there. And now I get to simplify. So this becomes doop, 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 10x squared plus 12. So f of g of x becomes 10x squared plus 12. So let's say I want to figure this out so I want f of g of 2. Just to put an example, that means that wherever there was an x, I'm now replacing that with a 2. So there's now an even more of a substitution. So I have 10, 2 squared plus 12, which gives me, let me put that in like that a little bit so I can see. I get 10 times 4 plus 12, which gives me 40 plus 12. Oops, sorry, I'm running out of room. And that gives me radical 52. So f of g of 2 gives me radical 52. Let's go ahead and do another example. I'm going to now do g of f of x. So now the bone structure and the pregnant baby, or the baby, is backwards. So g of f of x. So again, now this is the structure. So notice that's the bone structure. And now I'm plugging in the baby into that. So I have 5x plus 12. So notice where the input is now the actual function of the other one. So what is that going to give me? I get 2. Now this whole thing is a square root and the 2, so that's going to cancel, and I get 5x plus 12. So that's going to give me 10x plus 24. So g of f of x is 10x plus 24. If I want to find g of f of 2, that means I have now 10, 2 plus 24. That gives me 20 plus 24. So g of f of 2 gives me, running out of space again, gives me 44. So I hope you got a little crash course on function composition. Have a good night.